We have an array S that represents a chocolate bar, and this chocolate bar is composed of squares represented by each of these numbers in the array. And what we want to do is have a number of squares that is equal to the number corresponding to the month, for example 2 here for February, and these it's a number of contiguous squares, right? So we can have this two, we can have this two, these two, or these two here. And in addition to that, we need the numbers in the subsection of the array we take in the portion. We need these numbers to add to the day, the number corresponding to the day. Here it's 4 in our example, right? So here, if we take the first two, we have 2 squares which match the month, and the sum of the numbers on each of these squares is 4. It matches the day, so it would be one possibility. These two together only give 3, it doesn't work. These two together give 4, so it would be a second solution, and this together gives 5, so it doesn't work. So we have 2 solution, which is 1 and 3, which would be this one, and well, 2 and 2, sorry, 2 and 2 here, and 1 and 3 here. And we want the function to return not these guys here, but the function has to say how many possibilities, in how many ways can we achieve this, right? Okay, we have a couple of constraints. Well, obviously, number of days in the month, number of month in the year. This we don't really have to care about it, and well, this neither, because the numbers are given, but it says that we won't have a square with a number higher than 5. Let's check the code. So how are we going to do that? So here's the definition, and we are going to start. So we're going to have to, the function needs to return the number of ways. So we're going to start with a counter that says, well, number of ways for now is equal to 0. And other counter we're going to have, well, no, it's not a counter, but another thing we're going to write here is, let me show you. So here you have a chocolate bar, right? And let's say month here is 2, so it's also going to be 2 chocolate at once that are contiguous. So it can be these two, these two, these two, these two, or these two. So basically we can start from here, 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 and here, but we cannot start from here, right? Because there would be nothing on the right of it. So the length of the chocolate bar is we're not going to try for each of these numbers. We're going to try for each of these numbers up to a certain point. This is why we're going to write something here that is, let's call it, well, the start place, where we can start places, because they're going to be, well, let's call it start places. And we're going to see that, let's say this start places is going to be the length of S, right? Because S represents the array. But as we just said, it cannot be until the end. So it's going to be this minus the length of the month, and we have to add +1. Let me show you really quickly why. Again, let's take this one, and here it was also, well, also 2. So take this two, or these two, or these two. So meaning we can start the latest here, but we're not going to subtract 2. We're going to subtract 2 minus 1, right? Or we subtract 2, meaning we would start from -1, -2 from here. If we go back 1, go back 2, it's going to 2 plus 1. So it's always going to be, we always going to have to subtract the length of the month minus m and add 1 to achieve this. So we can start from any of these places. All right, so we are done with that. Let me just check. No, actually I have to close parentheses here, and there's no need for this one. Okay, now we're going to go with a for loop for I in range, and we're going to take this range here. This is why we created it in the first place. And so now if the sum, okay, if the sum, remember we have to count the sum on the total of squares that compose the portion. Sum. So the sum S. Okay, so from basically from a given integer in the chocolate bar, and to this integer plus m. Let me explain why we do this. Okay, in this array, for example, if we take, again, we have m equal 2. So if we want to go from this one to this one, This one is 0. Remember, the first number in an array, the first item is item 0. So this item 0, item 1, item 2, and so on. So we want to go from 0 to here, right? We're going to take these two here. And we have to say, okay, we go from I, if we started this is I, to I plus m. So m here is 2. So if we are 0 here and we go plus 2, we're going to go until here. Except when you have this kind of thing here, it means it starts at this one and it stops 1 before this one. So this is why we need I plus m, but actually it's not going to go from here to here. It's going to go from here to here because we tell it to go until I plus m, and it will stop just 1 before I plus m. This is how Python works. All right, so if the sum of this number of squares, we're going to put equal. We put 2 equal signs because we are not assigning, we're just checking if it is if it is what we want, if this is true, we're not assigning. And if this is equal to day, right? So it's adding the numbers on each of the squares that go from here to here. So if this addition here gives the same number as the number of day, well, this is what we want. It's going to be one of the ways in which we can achieve what the problem tells us to do. And not forget this. So if this happens, we want ways to increase by 1. So plus equal 1. So 0 becomes 1, and so on. And yeah, that's pretty much it. And we want the function to return the number of ways. Let's test this code. Let's see what we get. Seems to be cool. Seems to be fine. Let's submit. Yo, 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 bang! Here you go. Wow, have a good one, guys.